So good evening, everyone. Let me just give you a brief introduction of what I'm going to talk about. The title is pretty clear. Today, I think the data science, machine learning, artificial intelligence, they have become something like buzzwords in any business for that matter. Banking, all the BFSI sector is behind these buzzwords. And probably today, the typical manufacturing industry and everyone is behind this smart manufacturing, industry 4.0. So bringing in technology, analytics into the business has become one of the major elements in the today's industry. And I think we need to accept the fact that majority of the industries, without this has become kind of bread and butter to them. So just wanted to give you a brief intro into the same. So fortunately, or probably unfortunately, we don't see too much of insurance related courses in our typical MBA curriculums. Though I personally see that it's a huge business opportunity where there is a scope for a lot of firms to still enter into the market. The penetration levels are much lower, and probably there is a lot of challenge in terms of the mathematics that goes into the insurance calculations, etc. So there is a lot of scope and challenge that is involved in the insurance sector, but typically I see that the number of courses that are present in the B schools, either in the form of electives or core courses, in the insurance sector is pretty less. Now, just to give you a brief, that's the reason I thought I'll just give you a definition and then move forward. So typically speaking, you all might be comfortable that insurance is a means of protection from financial losses. So all kinds of contingencies where there is some probability of some loss to occur, and if that particular loss can be experienced by a large population, and if the probability of that occurrence of the loss is small to moderate, and these kind of losses can very well be pooled. The loss that is arising out of all these large volume of activities can very well be pooled, and probably the loss can be distributed. So that is how the insurance typically works as a concept. So probably if you are into the finance world, you talk about derivatives as a form of risk management. On the similar lines, you can very well think of insurance as a form of risk management. Primarily, the core definition of insurance is primarily from the perspective of risk management. And so any event, any unfortunate event, which can result in a huge financial loss, can typically be considered into the scope of the insurance industry. Though most of us may be knowing that traditionally life insurance or the general insurance, which is otherwise typically called as property and casualty insurance. Today in India, the broad divisions are the life insurance and the general insurance, which generally includes all the other things. So where you can talk about the property insurance, the casualty insurance, which is otherwise called as liability insurance, the fire, the marine, the automobile. So there are wide varieties of insurances that can be offered. Now, in all these things, the commonality is nothing but there is some financial loss that can occur. If it is a life, the person dying, the insured, the party who has taken the life insurance, let's say he has died, then probably there is a financial loss for the family. So to protect the family against the financial loss, there is some kind of a compensation that is being provided through insurance. Now, the insurance industry is typically loaded heavily with data. And there's a lot of data dependency. right from the stage 1 of the process, which means right from the product development stage to the underwriting stage, to the sales and distribution, to the claims handling. Everywhere there is lots and lots of volumes of data. Typically, just to give a number, we could see that at any point in time, the number of life insurance policies in India is per year, we are seeing somewhere around 35 crores policies. And when it comes to the automobile insurance, we see around 8 to 10 crore policies at least 8 to 10 crore policies per year. Data that the insurance industry is typically generating is pretty huge, which means there should be some kind of a mechanism to analyze that data, to make some kind of inferences out of the data, so that the right decisions can be taken and the penetration can be improved and the overall profitability of the industry also could be improved quite drastically. Now, we could see even today, the insurance industry, especially when it comes to product pricing, product development, reserving, there's a lot of dependency on data. And one simple example, if I have to say, a typical insurance business, let's say you talk about a life insurance industry. I'm taking a policy by paying a premium today, but the risk can occur anywhere in the next 20 years or 25 years. The death of the person can happen in the next 20 years, 25 years, or 30 years. Now, which means, how do I price it? How much should be the premium that I need to charge, assessing the risk of the person over the next 25 to 30 years? Do a lot of number crunching, and unless I do a lot of data analysis, doing a proper pricing may not be accurate and may not be appropriate also, given that there is a lot of regulatory involvement here. There is a lot of competition that is floating around. So unless I am able to do the pricing of the policy better, the next things in terms of claims handling, servicing, all those things can be much more improvised only if the core thing, which is the pricing of the product, is done better. Now, if you just imagine this scenario, today in India or even in many of the developed countries, the way the pricing is typically being done is by some basic arithmetic. Though the data is around 35 crores of policies per year, but typically the analyzing of that data is typically done in simple arithmetic. Okay, you simply divide the entire data into few clusters, and based on that do some kind of simple statistics like means and standard deviations, etc. And based on that, you get into the pricing for each of the chunks of data. But then there is not much of a tailor making in the products, monotonicity as a part of the pricing, because the number of parameters or number of variables that are typically being considered are very few in number. Though ideally you can talk about data being too huge, a lot of variables being captured, then are the insurance companies not able to do the pricing based on all these various factors? Age, gender, smoker stats. So except for 3 or 4 variables, you don't see majority of the variables being taken much into the base pricing. Okay, sometimes or nowadays you see that all the other things, typically whether a person's medical health, is a multiplier. So they simply come out as a load factor, and that load factor is typically applied to the final premium that is typically computed, right? Data is coming in various formats. The automobiles are fitted with telematics, lots of driving behavior, lot of information regarding the driving behavior of the customer. Social media, I think today is one of the major roles for every industry. And when it comes to the health insurance, we talk about a lot of connected devices, wearable devices, lot of sensors. So all these things, they are pumping in petabytes of data almost. So I should really have, now if I have to be unicorns. There is an Acco Insurance, there is a Digit Insurance, which are very relatively new players into the insurance industry, but they have gone that the unicorn status. And the advantage is they are the other side is they are purely digital. They are purely so they are purely using the data, capturing the data to do the traditional insurance business itself. So mastering the data is becoming very much increasingly important, and it has become the need of the hour. How do I analyze this data? That is the most important thing everywhere. Everything is becoming smart. A lot of automation is there. And the good thing today, the reason why people are going behind all these business intelligence, business analytics, machine learning kind of software is everything has become open source. In the industry, who is working are working either on programming software like R or Python, which are traditionally open source in nature. And of course, you have some licensed softwares as well, but most of the mid-sized industry, mid-sized companies in any of the industry, they are still behind this open source programming languages like R and Python, which means there is a lot of and the community that these programming softwares offers is traditionally like it's a kind of sharing everything. So open source, lot of collaborative works happening. All these things are driving towards this open source revolution, and everyone trying to use, even if I don't know much of mathematics, even if I don't know much of statistics, and I can execute machine learning to any extent. I can do a lot of statistical analysis without understanding what is the mathematics behind a linear regression, what is the mathematics behind a logistic regression. I can very well go ahead and I can use the framework that the programming language, and I can typically try to arrive at a solution, though optimal solution, but I can typically arrive at a kind of a solution. So almost all the companies in the insurance industry today, they have initiated some kind of projects towards this world of machine learning, because obviously all these are the needs that are driving. Learn from the data, just like the way you are learning something from the book, a lot from the book, you and I learn a lot from the videos. Similarly, we are saying I give some data to the machine and I am making the machine typically learn something out of it. So learning is nothing but generalization. Even when we do a learning, we do a generalization a lot. We have our own patterns of learning. Probably I learn by highlighting some specific paragraphs or some specific looking at the formula or the equation, and based on that try to derive the theory on my own. Or someone else have a different style of learning. Once I give you, each one of you has a different style of learning. Now that is where machines also, we are training the machines to learn things in different patterns. Now that is where various algorithms have come into the machine learning world. So you are trying to give some kind of a framework, and you are making the machine learn using that particular framework. For a small differentiation, for a traditional approach of learning versus the machine learning approach. In a traditional approach, to the data you give a program. Let's say you talk about a statistical learning. I give some data, a kind of a program. The program that I say is the error terms, let's say they follow a normal distribution. The error terms are normally distributed. And probably the relationship between y and x is typically coming out as a plus b1 x1 plus some kind of epsilon. So we are giving some kind of a program saying that the error terms are normally distributed or something like that. And based on that, we are asking the system to forcibly fit your data to that particular program, and based on that arrive at an output. That's a typical traditional way of learning things. You have a pre-built program and you are inputting data to that particular program and you are arriving at an output. Whereas the machine learning way is slightly the other way. You are giving a data and along with that you are giving an output. What is that you want? So what is the input? What is the output? So for a simple example, if we say the output is whether a person has committed a fraud while submitting a claim. Was it a fraudulent claim or not? Or was it a suspicious claim or not? So that is the output. The input is what are all the drivers to that suspicious claim. So from the past data and from the historical thing, I'm giving a set of data, which is all the drivers for a suspicious claim and a historical record of whether I'm giving to the system machine and I am asking the machine to typically generalize something. So I'm asking from it, generalize something. The generalization is, remember it, abstract. From the data, from the output, create a kind of an abstraction so that if at all you want to do some kind of a prediction on some new thing, it can very well be taken care of. So there are different forms of learning. Supervised, when there is a teacher, when you know what is your target and you want to learn in line with that target, then you call it as a supervised learning. You don't have a target, you identify some kind of patterns in the data, then it becomes an unsupervised forms of learning. And it actually, if you look at the algorithms of the world of the information from various domains as such. And this is like about, if you say I am good at machine learning, out of all these various techniques, how many are you comfortable with? And this is all different ways of learning, nothing beyond this. When we are using this, are different ways of learning from the data. Probably all of us might have used linear regression in some form or the other. Now, linear regression is also, if we see here the linear regression is also a form of learning. Similarly, some of you may have experienced, let's say, a logistic regression. Some of you may have talked about or may have heard about clustering. So some of these things you might have come across, which are the various algorithms that can go in the machine learning landscape. And of course, this list is keeping on emerging because newer and newer ways of learning from the data is typically coming up. So just like any other project, you can typically talk about a machine learning project. Initially, you are getting the data. The data can come today from any source. You can talk about a very structured data in the form of tables, databases, or a very unstructured data. That is where the core of machine learning is coming in. You have a lot of unstructured data in the form of text, in the form of audio, video, images. You can have the data in any of the forms. You should have some kind of a mechanism to pre-process that data, to use it in a way, to convert it in a way that various learning algorithms can be applied on the top of it. So there is a lot of data processing and pre-processing that is going on. And once the data is created in such a way that a machine learning model can be applied on the top of it, you try out various machine learning models. So machine learning models or machine learning algorithms are nothing but the way you are trying to connect the inputs with the output, the drivers of a particular outcome to an outcome. And so which of these, now how well the relationship between the input and the output is established. So for that, you need to have some kind of evaluation mechanisms. So which which of these algorithms is able to learn the input well in line with the output. So you may try a set of such kind of algorithm, and whichever is found to be the most appropriate fitting, you would try to go with that. Now, coming to the insurance industry, right? Insurance industry, the reason why it is behind. Today, lots of insurance companies have opened up specializations in artificial intelligence and machine learning across the country or even across the world. So, which means there are so many opportunities in the insurance sector, especially if you have specializations in the world of AI and ML. The data is coming in large volumes, which we have already discussed. There is a potential for a lot of automation. Traditionally, if you see, most of the insurance companies, even till today, they have a lot of their applications in the traditional legacy systems like mainframe databases, etc. And compared to the banking and the capital markets domains, you don't see too much of aggression till date in the insurance industry. So which means many of the processes are still either in a manual form or with a very basic level of automation. So which means there is a lot of potential for automation, lot of decision. Now policy, if I am talking about a typical life insurance policy, yes, earlier it used to take even a week or more for the policy to be issued, but now things are much better off. But now there is a lot of research that is going on in terms of instantaneous policies, though some of the insurance companies have initiated that process for small sum assureds, but trying to analyze the data of the policy holder from various sources rather than only the submitted application. Many of the time, the insurer fills a kind of the insured, the policy holder fills a, and based on that application form and based on the detailed application form, a lot of assessment typically happens. But today, with the data available from various third-party sources in various formats, there is a lot of research that is going on. There are a lot of projects that are initiated in terms of capturing that data regarding the customers automatically from their mobile phones, from the mobile phone usage, from the usage of the telephone networks, a lot of other things. The data is coming from various sources, from the social media usage of the customer, etc. All from the various sources, that a lot of potential for automation. And as I have also talked about, the competition has increased a lot, which means there is a search for efficiency always in almost various lines of business within the insurance, various functions within the insurance domain. There is a lot of search for efficiency. So now some of the projects which are undertaken by some of the insurance companies in India by using the machine learning is something that I thought I should highlight. These are some serious problems in the insurance apps. Policy lapses and reinstations is something a very, very serious problem in the insurance sector. Right now, trying to identify what kind of people, what profile of policy holders are primarily lapsing their policies. There is a serious effort because it actually costs a lot to the insurance company. So today, by using various classification models of machine learning, the companies are typically trying to analyze the drivers of lapsation and trying to prevent by introducing some kind of activities post the when they are approaching the typical so that the policy does not get lapsed. So automatically the machine learning is trying to identify the profile of the people and based on various criteria. The second one, I think that is where the insurance industry is making a very good progress. Insurance recommendation engine, which is also another machine learning tool or technique that you can say. recommendation systems. So for what kind of person, what kind of policy can be recommended by taking a lot of course, today they are still in the very nascent phases, but understanding the characteristics of the customers, understanding the characteristics of the potential applicants, trying to recommend what is the kind of policy that they should go for, needs analysis, etc. There is an automated thing that comes in by applying previous customers who have purchased various kinds. Today, the other important domain is aid to the loss surveyor. So today, when an accident occurs, earlier all of you, at least some of you might have experienced, when there was an accident or something, you may have to take the photographs of the accident. You have to the loss surveyor comes, looks at the vehicle's condition. So there is a lot of physical involvement, physical person involvement before actually a claim can get initiated. But today, using the smartphones, etc., lots of lots of data sharing is happening. Drones are there to analyze the overall claim damages. So some companies, some private insurers have actually initiated these kind of projects as well, where the data can typically learn. Or even there were a few projects which talk about what are the most heavy accident prone pin codes. Earlier, when I was the head of analytics with IRDA for a brief stint earlier, we were doing one project in terms of identifying at a pin code level what is the kind of loss experience for, let's say, motor insurance policies at a pin code level, at a lat-lon level, in terms of what are the high risk prone areas. Which means now what can happen? That insight can very well go into the pricing. That insight can go into the pricing. Today, when we talk about the pricing for a vehicle insurance policy, those inputs are typically not being considered at all. So, which means when I'm able to analyze the data, when I'm able to process the data a lot, we could clearly see that new projects can give scope for better pricing, better customer acquisition, and even bringing a lot of flexibility into the product design as well. And today, the most important problem that the insurance industry is facing, probably the entire financial sector is facing this problem, but the insurance industry on a very, very serious note, the fraud. So, and lots of millions of dollars are typically poured in terms of handling and battling this fraud. So even if there is a small solution which can really identify the suspicious claims to start with, forget about the fraud, even if we are able to identify some suspicious claims, then the claims team or the fraud team can typically take up these particular claims and they can do a further investigation into the same. So there are lots of machine learning models which are using various drivers in terms of identifying the fraud. I think most of the insurance companies have initiated some kind of projects around the fraud identification. Then experience studies. So identifying all the claims that have been filed over the last few years. So understanding the profile of each of the claims, both from the customer perspective, policy perspective, duration perspective. So there are various drivers to the various claims. So trying to identify using various machine learning algorithms, what are the drivers of various claims? So that again, once I am able to identify the right drivers, I would take those drivers into the pricing. If you look at all these things, the root is how well I am able to price the product. Now, unless I know which variable, till now it is like theoretically I know that this variable could contribute to the loss. For example, theoretically, let's say vehicles which are very age old, they contribute more to the loss. Or very, very new vehicles, they contribute more more to the loss, because there is a possibility that there could be an entire vehicle that can be replaced. So the cost, the replacement cost could be much higher for a very new vehicle. But to what extent the data is supporting them? Unless I do an experience studies in terms of which kind of vehicles are very heavily resulting into claims, and is it a consistency or is it a one-off thing? Unless I get into some such kind of mechanisms of experience studies, I may not be able to do a better pricing. And probably there is a lot of discussion internationally talking about bringing in personalization into the policies. So usage-based insurance. I think today that's a lot of there's a lot of buzz that is going around that usage-based insurance, which means lots and lots of personalization by trying to identify the various aspects of the customer, of the item that is getting insured. So machine learning as such, there are a lot many other applications like claim processing, lot of automation, customer service, better segmenting the customers, pricing, flexi pricing. So lots of areas where the various machine learning algorithms can be put to use. And I think today insurance industry in India also, forget about the international also had made started making progress using data and analytics only in the last 1 decade. But India also over the last 6 to 7 years or slightly close to a decade, in India also lots and lots of the machine learning and data science related projects have been taken up, especially in areas where regulator is not that heavily involved. So today the pricing is still going on in lines with the guidelines given by the regulator. But for various other activities which are more and more internal to the firm, except for the pricing and reserving, these are two major areas where actuaries typically come into picture in the insurance space. Except for these two areas, which are still a lot guided by the regulator, in the other domains, we typically see there is a lot of inroads going by using the usage of machine learning. But of course, I think this does not come with, this is not a free lunch. There are a good number of challenges, because the most critical thing that at least I have observed, bringing that data-oriented culture into an organization is a very, very difficult thing. And especially in an insurance industry, which has been a very traditional industry for quite some time, with so many senior people coming from a traditional mindset, bringing in a data-oriented kind of culture toward decision making is a very, very critical task, which has to actually come from the top. That is where you guys should really look at lack of specialists combining the actuarial know-how with the machine learning expertise. Today, the machine learning expertise, even among the young children, young students, participants like you as well, is not to the extent that the industry is expecting. Though majority of you might have done some kind of programming at your school level itself, whether it is Python or any other Java kind of programming, many of you might have done at your schooling level. But trying to integrate that learning into the bigger picture of solving a problem is something that is lacking. So which means whatever the machine learning that people are learning are typically using the videos and some kind of third-party sources is not getting sufficient to solve a problem because of the lack of business understanding around it. And which means even in the educational institutions like the IIMs, it's a very much necessity now to bring in more and more programs that dwell around the data analytics. I think most of the IITs have brought in some form or the other, and even in some of the IIMs have seen these kind of programs. But a lot of rigor is very much required in terms of integrating these programs with the industry, which will actually solve a lot of problems. And of course, data privacy is these are the things that people keep discussing quite often. The ethicality is the privacy related things, and the security related aspects. Of course, technology is definitely evolving, both for good as well as from the perspective of bad. But at the end of the day, unless the technology evolves and unless the technology takes over, I don't see any progress typically being made. So obviously, there would definitely be some kind of challenges. But overcoming the challenges and trying to provide the better decisions is the way the insurance industry, or for that matter, any industry, has to move forward. But just to give a kind of a quick summary before I think I stop my presentation, just to give a big summary, insurance industry, I think, is something that all of you should typically be looking at. Obviously, it's it might not look as lucrative as the capital markets or the banking domain for majority of you from the outside world. But typically, if you get into the roles like actuarial roles or the machine learning, data science oriented roles, etc., even the data that is available in the insurance industry is so vast, so huge, you would really be enjoying any kind of a decision or any kind of insights that you pull out from this kind of a huge volume of data. And thanks to the insure tech, which is the kind of which is the new buzzword, or which is the new thing that is coming in the insurance world, right? Just like a fintech, it's a branch of fintech, insurtech. A lot of disruptions that are happening in the insurance industry, especially relating to the customer handling, policy servicing, claims management, etc. So in these areas, the traditional insurance space and people from the new generation, especially participants like you, should really need to capture this kind of an opportunity and try to position yourself in the insurance sector accordingly. All right. So I think I'll stop it here, though I have a few slides giving you a kind of a case study in the insurance pricing, motor insurance pricing, etc. Probably I'll stop it here in case this is fine. So I'll be taking some kind of questions in case anyone.
So let me just start. Vamsi, though of course I don't understand machine learning and all this stuff, but you presented very beautifully, gave a very good overview of how this works. But my question is that, how do you see a company like LIC facing competition? Because obviously they have their legacy issues, they have their inertia. Will they be able to quickly, gear up to face the competition from the newbies of the insurance world?
Sir, the newbies, okay, till now, these tech-based companies have not entered completely into the life insurance market. So most of the tech-based companies, whether it is ACO or Digi Insurance, who have entered into the life insurance, who have entered into the digital-based insurance market, they are in the general insurance sector itself. And in the life insurance sector, even after a privatization of almost 20 plus years with ICICI, Prudential, and few other players existing even for the last 20 years, the market share of LIC has reduced only a bit. It did not fall down so drastically. And for your information, LIC also has a very good investment in the technical. It has a very strong technology team, and I think it is having a very strong team of analytics professionals, etc. So which means they having big data repositories. There is a lot of analysis that is going on the data, and they are more or less in line with the competition also. Of course, they have a good prime mover advantage. They have a lot of trusted customer base, etc. But still, even at this moment, I see that because of the regulator, because of the support from the regulator, and because of their internal processes also to some extent, I don't see a tough or probably, I mean, at least in the next decade or so, I don't see too much of surprise things that are happening with respect to the LIC.
There's a question from Sandeep in the chat box. He's
Yeah.
asking about certification courses in this field.
Okay. Certification courses wise, if you are looking at traditional insurance as a sector, you have certifications being offered by Insurance Institute of India. So they offer 3 levels of exam, which is called licentiate, associate, and fellowship. But that is purely from an insurance domain perspective. That is one side. The second side is the actuarial side, actuarial side of insurance, which is primarily about pricing and reserving. So using mathematical, econometric, and a lot of these data-oriented statistical models, you try to do the pricing of the products. You try to do the reserving for various claims, individual and aggregate. So for that, you may have to go with the actuarial exams, which are conducted by Insurance Institute of Actuaries of India. So they have, I mean, typically they conduct around 13 exams. Earlier it used to be 15, but now it became around 13 exams. And you may have to clear 13 exams. So they range right from your financial engineering, financial mathematics, to economics, to mathematical modeling, statistical modeling. So you may have to do these kind of courses, which are very heavy and intense. The average time to complete this certification is around 5 years, or probably more than 5 years. So you may take around 6 to 7 years. But yeah, this is something that you can do parallelly with your work. So that is one more area, but they are very lucrative. And just to tell you, I don't know, there is one student from our junior batch, 2002 pass out, 2002 batch, but he did not complete with IIM Indore. He just joined for 3 months, and I think he quit the program. Probably Vikas must be knowing Abhay Tiwari. So this person right now is he is the qualified actuary just like me, and he is the head of SUD Life insurance company. So the opportunities when you actually go into the actuarial space, especially in the insurance sector, the opportunities are too much, and there are very heavy chances of you being a part of the senior management at very early stages of your career itself. Okay, Sandeep is asking any recommendations for machine learning and data science course. Yeah, if you have some electives with respect to machine learning and data science at IIM Indore, I think that should be your first priority to start off. Otherwise, my suggestion is Coursera has a good number of courses. So you have to just look at some courses. Now the machine learning is something like it can go very technical, basically going into the mathematics and the mathematical formulations, etc. Sometimes it may go very much overboard. But on the other side, it might be more of management oriented, which is an applications part of machine learning. So Coursera has both set of courses. So you should typically choose the one, I mean, depending on your interest, probably I initially started off with the technical and the mathematical because of my actuarial background. But after that, when I started listening to the management oriented videos from Coursera, I think they were very interesting also. So you can very well start off with the management oriented, the ones that are offered by the B schools. You can very well look at those videos as well. And even on the NPTEL, which is, I think it's a platform that is floated by all the IITs. There are a few courses offered by IIT Kharagpur on the machine learning and data science. So probably even you can look at those videos, though they would be a little bit more on the mathematical and the technical side as well. Okay, but I think most of the IIMs are offering electives in the area of machine learning and data science, at least a few electives of business analytics. So probably if they are there, I think you guys should really look towards that.
Thanks, Professor Vamsi. It's been really insightful. But my question is, so I'm associated with a insurtech company as of now, and as you said, there is a lot of data, and we have to make meaning out of that. So I don't understand where to start from. For using those machine learning tools and stuff, because I also have to deal with a lot of data, and the challenge that I face most commonly is about the data structure that is not in proper format, that is unclean, that is also accuracy issues. So where do I start to? So my company gives me enough free hand in terms of what I can do to make things better. And apart from my the core function that I lead, I can also have a voice in other areas of focus that is there in high level meetings. So maybe I need a direction where to start from.
Yeah.
How do I overcome the accuracy and the data cleanliness issues in terms of
Okay.
availability?
I think this problem is a universal problem. First thing, I mean, the data not available in the right format, and typically in the industry also we say 80% of your time that you spend on a machine learning project or a data analytics project, you spend on just cleaning the data or preparing the data in such a way that you can apply some kind of learning on the top of it. So even in a typical consulting assignment, which spans for 1 year for a complete end-to-end project, almost we find 7 to 8 months going in purely in terms of cleaning the data and preparing the data in the way the models can be applied. So this is not a kind of a specific problem. I think this is a universal problem, because the data is collected for some other purpose and we are doing an analysis for some other purpose. We are not exclusively collecting the data, keeping a project in mind. So we already have some data. We are creating the project on the top of that data. So obviously these two may not be matching, which means you will have to spend a lot of time in terms of cleaning the data. But again, there are frameworks today. I mean, if you follow a kind of a process or a framework kind of a mechanism. So typically, if we talk about machine learning, we talk about CRISP-DM model. So there are a few such kind of processes that are there. So if you follow the process and is available in terms of what are the various data cleaning steps that you have. So there are like 5 to 10 steps that are listed out. So in each of the cases, you will have to, it's a kind of a checklist. So probably you can make it more and more automated from that perspective as a kind of a checklist. Have I executed this step, etc. So which means you are going step by step, patience. And obviously a domain understanding is the most important. Probably you cannot take out that domain understanding. That's one more area which is a kind of a misnomer. People feel if I know R and Python and if I know some kind of programming, then I'm a machine learning expert. So that has become a kind of talk today in the industry. So whenever I talk to any B school student, are you good at machine learning or are you good at data science? The first answer I get from him or her, yes, sir, I have done a course in Python. Learning. The first thing people give as an answer is R or Python, which traditionally is not the case. There's a lot of concept which you are trying to execute that concept with R and Python or any other programming language for that matter. So which means unless I know the entire framework where how to lead to a solution, because even if I'm doing it on a non-machine learning oriented, not data analytics oriented also, I have a way to solve the problem. Now I am solving that same problem by picking up the data. So how clean is my data? How appropriate is my data? I have to spend time to correct it and to make it in a fit in a way for utilizing the model.
So thank you, Vamsidhar. I think it was a brilliant presentation. I think you can take over from some of us.